Alright, here we go. Problem 6. Alright, a professor gave a statistics final to 32 students. Here's the dot plot. So here I have my dot plot. It says the center of this distribution is approximately where? Alright, so they said center. They didn't tell me mean, median, or mode. So here's what I have to go off of. If I've got 32 students, the center is the middle is going to be really close around the 16th student, right? We cut 32 in half and we get 16. So let's count 16 points. So you know 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The 16th point is right about here. Okay, that number seems to be somewhere between 78 and 84, a little bit closer to the 78 mark. So that looks like C, 80.5. All right, 7. Says below is a histogram of the gold medal winning high jumps for the Olympic Games. And they said the mean of this histogram is approximately blank. Okay, so if I'm looking at a graph, we said the mean is the balance point. Okay, so I come over here with my finger and I said, okay, where can I put my balance point to see where this is? If I try to balance it right in the middle here, it looks like it's going to tip over to the right side. So that does not look like a good balance point. If I slide it over just a little bit and I put my balance point here, okay, it looks a little bit better. So my balance point, this thing is going to be probably close to right around here. So the left side and the right side seem pretty balanced. So this number is really close to 82 inches. Okay, next part says the percentage of winning jumps that were at least 7 feet, so at least 84 inches. Okay, so now I come up, and 84 inches is right here. Okay, now here's the biggest problem with the histogram. I know that I've got 10 people somewhere between 80 and 85. Those 10 people all might be right in the middle at 82. They might be at 85. I don't know where they're at. So I really don't know much about this bar. I don't know where these 10 people are located. So I'm not going to use them in my calculations. All I know is I've got the percent of cases from between 85 and 90. It looks like it's about 25%. And in this bar, it looks like it's about 10%. So total is going to be close to about 35%. Let's see if that was an option. 35% was an option. There we go. Answer is D. All right, moving on. Okay. A set of data has a median that is much larger than the mean. Okay, so if I'm going to draw this distribution, my median is going to be over here, and it's larger than the mean, so the mean is going to be slightly less. Okay, so because my mean is on the left side, that means the mean is getting pulled to the left because of skew and outliers. So that means the skew has to be on the left side as well. So this graph is probably going to look something like this, right? Shows me having a left skew. So my answer for this one says the stem plot of the data is skewed left. All right, number 9. A reporter wishes to portray baseball players as overpaid. Which measurement of center should he report as the average salary of major baseball players? Okay, so we have to understand what the baseball players' salaries look like. Okay? Now, some baseball players make a ton of money. They make $30 million a year, $40 million a year. So there's going to be players up there that are making $40 million. Okay, but there's not that many. A lot of the players are probably getting a lot less money, you know, probably around the league minimum, somewhere probably around $200,000 a year. So we're going to have a lot of people in this range, right, making somewhere between $200,000 and maybe $1 or $2 million. Okay, this is where the bulk of my data is going to be. And then as I stretch out towards 40 million, the number of people that are getting that much money is going down and down and down. So this is pretty much what my curve looks like. I've got that nice right skew. Okay, So to me, here's the mode. The median is going to be a little bit further to the right, and the mean is going to be way out to the right. Okay? So if this reporter wants to portray baseball players as overpaid, that means he wants to say that they make too much money. So which of these values are going to show that they make too much money? It's going to be the one furthest to the right, which happens to be the mean. Okay, last one. Okay, it says, which of the following is likely to have a mean that is smaller than the median? So the mean is going to be here, and it's going to be less than the median. So the median is going to be over here. So because the mean is on the left side, this is telling me I want something with a left distribution. I want a left skew. So let's see how this looks. All right, A, the number of candy bars sold in a movie theater on a randomly selected day. Well, no, that's just going to be a number. Like how many candy bars did they sell? Well, it might be 100 candy bars. That's just a number. You really can't get a distribution out of that. So A is gone. B, the scores of students on a very easy exam in which most score perfectly but few do poorly. Okay, most are scoring perfect, right? We got few, but then a few are doing very poorly. So as we drop, it would drop off as we go. So to me, B is the obvious answer. Okay, we can go through the rest if you want to, but just to save time on this video, none of these are actually going to end up working. Okay, we did prices of homes in Addison. We did that earlier this year. So we showed that this had a right skew. The scores of students on a very difficult exam, which most do poorly but few do well. We did this one in class 2. That's got a right skew. And the salaries of all national football players, that's probably going to be similar to the one that we did up here for baseball players, which also has a right skew. So B is the only one that sounds like it would work in this case. All right, so that takes us to the end of this page. So if you have any questions or any of these examples didn't make sense to you guys, come on in and we'll go over it. All right, good luck.